All right, we are starting chapter 7 now. Now, for 7.1, we're actually going to spend 2 days on these notes, but I'm going to put them all together in one video. So I will make a note where day 1 and day 2 are. So day 1 is all about vocabulary. No calculating, just mainly vocabulary. So we are starting with monomials. Mono means one, right? Mono means one. I'm sure there's a Latin root somewhere. But a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. So the key word is product. It's all connected by multiplication. There is no addition or subtraction. So it could be numbers and variables, but it's all connected by multiplication. Now the degree of the monomial is the sum of the exponents of the variables. Okay, so the sum of the exponents of the variables. If there is no variable, okay, if it's constant and there's no variable, the degree is 0. 0, if your number is just 0, it does not have a degree. But if it's a non-zero constant, then the degree is 0. So we can see some examples right here. So the number 10, it's a non-zero constant, the degree is 0. Otherwise, the degree is the sum of the exponents of the variables. So 3x has the invisible 1, right? So that's why it's a degree of 1. The next example, 1/2 ab squared. Remember, a has the invisible 1. So 1 plus 2, the degree is 3. For the last example, the degree is 5. It's the only variable. Now, on the right here, these are not a monomial. Remember, a monomial is all connected by multiplication, so that addition sign makes it not a monomial. You can't have a variable in the denominator. You can't have a variable exponent. And the variable must have a whole number exponent. And whole numbers are 0, 1, 2, ... No negatives. All right, so maybe we should say, I want to emphasize that up here, whole number exponents, okay? No negative exponents. All right, so moving on, we are going to do some examples. If you want to stop and pause it and then come back, try them on their own, that would be a good idea. For A, the degree of this one is 2. For B, invisible 1 on the x, so 1 plus 3 is 4 for a degree. This one is 3 plus 3, or 6. And this one is a degree 0. Again, non-zero constant, degree 0. So all of those are monomials. A monomial, all connected by multiplication. So a polynomial is where we have one or more monomials connected by addition or subtraction. They just say sum, but we can always add the opposite. So a polynomial is a monomial or sum of monomials. Specific terms are, if it has 2 terms, it's called a binomial. And if it has 3 terms, it's called a trinomial. Otherwise, we just say polynomial. We could talk about the number of terms. We could say a 5-term polynomial. But like I said, binomial, 2 terms, and trinomial, 3 terms. And the terms are separated by addition or subtraction. So here's our 2 terms, and here's our 1, 2, 3 terms. Each term is a monomial, and they are separated by addition or subtraction. Some more terminology. So the degree of the polynomial is the greatest degree of one of its terms. So if you look at the degrees of each of their terms, whatever the greatest is the degree of the polynomial. Standard form is when the exponents decrease from left to right. In other words, highest degree to lowest degree is standard form. And finally, the leading coefficient is the it's the big number in front of the first term when it's in standard notation. And so that's why it's the leading, it's the leader, right? It's the beginning of that polynomial. So let's look at this example. We have, write this in standard form. We want to identify the degree, leading coefficient. So right now it's out of order. This needs to go first. This will be second, and this will be third when we put them in order. And we can see that right here, down here is the answer, okay? So this right here is our standard form for that polynomial. Once we put it in standard form, we can see that the degree is 3, okay? Remember, that's our leading term. And the leading coefficient is -1. Let's try some examples. So for this one here, it already is in standard form because there's nothing to rearrange it with. It's a monomial. We want to identify the degree and classify by the number of terms. So this is a, well, let's say the degree is 4. I'm going to also do leading coefficient. Oops, leading coefficient is -3, and it's a monomial based on the number of terms. This one we need to put in standard form. So this would go first, then the x, then the 4. So the degree is 2. That's the highest degree on our first term there. Leading coefficient is 5, and this is a trinomial. This last one, to put it in order, it would be that first, then that. The degree is 5. Leading coefficient, invisible 1. And it is a binomial. So all of this is important. This is the assignment today. This is all we're doing for day 1. And the assignment will reflect all of this vocabulary: leading coefficient, standard form, degree, binomial, monomial, trinomial, all of that stuff. So now day 2, here's day 2. Day 2, we're now going to add and subtract polynomials. Now, we can only add things that are the same. So when we look at, say, example A here, we can only add things that are alike. The parentheses aren't doing much for me. We don't even need the parentheses. It's plus. We're going to add things that are the same. So you might notice these are the same. It's kind of hard right now because it's not in standard form. So you might want to rewrite each part in standard form, or just underline like I do to help you add things that are the same. Now, there's 2 methods of doing this. One method is the vertical format. Not my favorite, but I'm going to show it to you because it's in the book. That's when you write them on top of each other, lining up the like terms. So you can see the 2x cubed minus 5x squared plus x, and now the second parenthesis, they rearranged it so it looks like x cubed plus 2x squared minus 1. So when things are lined up, you can just add like you normally would, down each column, and we get our final answer. The other way, which I prefer, I think you would prefer, we're going to do this one in the horizontal format. And so when it's like this, we just, you can underline or just cross off as you use them, things that are alike. So 3x squared plus 1 more x squared gives us 4x squareds altogether. Switching colors, 1x plus 4x's gives us 5x's altogether. -6 plus +10, +4. And there we go, that's our answer. So let's try these now. If you're watching the video, well, obviously you're watching the video, pause it, try these on your own, and then resume to check them. So combining things that are the same, 1b plus 4b's gives us 5b's altogether. -10 plus -3 is -13. So that would be our answer. For this one, we have x squared, 1x squared plus 7x squared gives us 8x squareds. -1x plus -1x is -2x. And then -2, that's it. So that would be our answer. So combining like terms. Now subtracting polynomials is very similar, but what we have to do is, because of this subtraction sign, we have to, it's kind of like there's like a -1 in front of here. We need to distribute that negative sign to everything in the second parenthesis. Another way to think of it is the keep, change, switch. So keep the first part, 4n squared plus 5, change, and then switch everything in the second parenthesis. I guess I didn't need to write that here. We can just make those changes. So keep, change, switch. So when we switch everything in the second parenthesis, now it's an addition problem. So we can combine 4n squared plus 2n squared equals 6n squared. That's my only n term, so -2n. And then we would have 5 plus 4 plus 9. Keep, change, switch again. Keep, change, switch. Change the signs of everything in that second parenthesis. Now when we adding the p squareds, 1 plus 4, we have 5p squareds. P plus p is plus 2p. And then 3 plus -3. Actually, those cancel out, don't they? And so that would be our final answer. Last one, pause and then play if I'd like you to try it on your own. Keep, change, switch. So -3 plus -2 is -5x squared. There's no other 5x's, so plus 5x. And then -7 plus 3 is -4. And there you go. Adding and subtracting polynomials by combining like terms, and keep, change, switch when it's subtraction.